Ooh, does this help?
Yep, perfect.
This is better. Okay, cool. So, hey everyone, thank you for joining. My name is Mohamed. I'm a software engineer at Confluent. I work with the product security team, which is a part of our trust and security organization at Confluent. Today, I'll be talking about SPIFFE and SPIRE, like what's our experience with it, what we've learned trying to scale it. If it feels like I'm skipping over some details that you'd be interested in, it's because of the time constraint. That's how I prepared my slides. And so if you have questions, definitely feel free to reach out to me after the talk. You have my contact information here. You can find me at the SPIRE Slack channel. Let me give you some context about like the lay of the land from an infrastructure perspective at Confluent. We're in three cloud providers: AWS, GCP, and Azure. We are in more than 100 regions. And so something I want to point out here is that we always take into consideration that we do have pay close attention to generally, and was no exception. We have thousands of K8s clusters, tens of thousands of nodes or hosts or VMs. We have hundreds of thousands of workloads. So workloads here, by the way, are not just physical workloads where each Kubernetes pod is a workload, but they're also we do also have like multi-tenancy and multi-tenant loads that provide isolation below the pod level. That part is very important. This is like basically workloads that are spun up by our customers, right? And so you can think maybe like the number of our workloads in terms of like SPIRE and even otherwise are like very dynamic, right? They just scale them up and down, and it's something that gets basically shrinks and expands, based on like the customers creating workloads and whatnot. So why SPIFFE and SPIRE? So some context about how SPIRE ended up being the solution we chose to implement. So here at Confluent, we take a proactive approach with security as opposed to a reactive one. We have a trust and security org that I mentioned that takes, that's constantly working on improving our security posture. And so workload credentials distribution in a scalable manner is a challenge, right? And about 2 years ago, my team, and actually a member of them is here with us in the talk, Arvind, got tasked with identifying a solution that makes our distribution of workload credentials more scalable, and also one that consolidates our service-to-service authentication solutions that we already have. Zero Trust is a model we follow, and we're constantly working on improving. So my team identified and proposed SPIFFE and SPIRE. It was pitted against another in-house built solution. And what set SPIRE apart really from the other solution were many things, but just to name a few, the elimination of secret zero through the concept of attestation, short-lived tokens that are automatically rotated, and the fact that we can have some level of security isolation through trust domains and trust domain federation and whatnot. So that's that. Next was convincing people. This was fun. So preparing the humans is actually a phrase I borrowed from Solving the Bottom Terrell book. If you haven't read it, I really recommend you to read it. And so this process involved a lot of convincing, getting buy-ins from different teams and the org as a whole. This involved like building a solid case for SPIFFE and SPIRE. This is both right to help
did we lose him?
To make adoption or the adoption journey easier things like identifying current solutions that can be integrated with SPIRE seamlessly and transparently. For instance, we do have like a solution that provides consumers with credentials, and the underlying implementation could just be switched to have SPIRE be the source of these credentials. I think identifying things like that early on definitely helped. So once we were past that phase, we designed the solution, which I'll be talking about in a bit. At a later phase, we then started involving like a small subset of service owners to to bring them up to speed, to basically identify any potential gaps in the overall design or needs that we need to cater to. And then a later phase involved bringing potential partner teams like our SRE team up to speed with the design and onboarding them, as they would be like the owners of the infrastructure part of it. So that being said, let's talk a little bit about the design itself. So designing the topology, first thing we looked at was the number of trust domains. And we sort of went in a progression, starting with the simplest, most naive option, evaluating each option as we go, right? And really the main areas we looked at while evaluating each model or each option were security, availability, operational overhead. This is in terms of like the footprint or the deployment footprint size, right? And managing federation relationships, etc. And then lastly, performance. This is, and basically here, like two things we paid closer attention to is like the concern with like the bundle size being big and the impact it has on the overall like SPIRE deployment, and like avoiding having the database being the bottleneck through like making going with like a nested topology within each trust domain versus like an HA deployment. With trust bundles, like, to be honest, that's not even something we entertained measuring, because even if our current infrastructure scales fine and has no problem basically with when it comes to like the bundle size, we do keep adding regions. And these cloud provider regions is like, these are the regions where we allow our customers to spin up new workloads, right? And so as we add regions, we at some point these regions will have SPIRE servers. And so at some point we will use JWTs, right? JWT SBs. And as you know, like each of these servers or cluster of SPIRE servers will have its own public key for JWT keys, and so which then contributes to the overall bundle size. And so that's something we wanted to avoid. Like even if our current situation is fine with this limitation, we just don't want to put ourselves in a situation where like in the future, adding more servers or trust domains would basically put us back in this situation. Okay, so with that being said, the first model we looked at is a single trust domain. And before we go through the 4 areas in this model, if you take a look at the diagram, and specifically like the first, like the top part of it, the cross cloud provider hop between root and like the downstream servers for attestation, and also for just like ongoing communication between, like in that flow between the root and the downstream servers. That's something we didn't really like for a couple of reasons. One maybe I alluded to earlier, like the relative frequency of cloud provider to cloud provider communication failures versus if we were to have this within the same cloud provider or even region. That's something we wanted to avoid. The other concern was has to do with security. It's like the attestation, right? We want to use cloud provider node attestation, but with such setup, if you imagine the root being in like a different cloud, it will have to be in like a different cloud provider than like at least a couple of the downstream agents it's trying to attest, right? And so what that means is that we'll have to inject some sort of like secrets in the root so that it's able to call, like if it's, for example, in Azure and it's trying to attest an AWS downstream server, we'll have to inject some probably AWS tokens in root so that it's able to call the AWS APIs to be able to validate the AWS token that's coming in from that downstream server. So we didn't want to get in that. The other option was to use a different kind of node attestation for that first level, which also means that we'll have to manage some certs, because if, for instance, if you use X509 POP node attester, we will have to have like a way to like manage, the like keys and certificates, like the keys that are used to generate these like self-signed certificates for the agents to be able to attest, or for the downstream service to be able to attest. If we were to use gates, node attesters, we will also have to, inject some sort of secrets in root, so that root is able to call like the token review API of like these downstream servers with the Kubernetes clusters of these downstream servers. So that's the first thing I wanted to point out with this model. Now going through the 4 areas with security, I think we touched on that a little bit. It was that wasn't a great option for us because of the reason I mentioned about node attestation, and also like in general with a single trust domain, if you have a compromise, like you don't have any sort of like security isolation, so so everything is basically compromised if it's a single trust domain. From an availability standpoint, again, as you know, if like root is down for an extended amount of time, then your whole deployment is not available. Obviously, like TTL is something you can sort of mitigate this with, but we didn't just want to rely on that, right? Like rely on a config basically to do that. And then operational overhead. This is probably the smallest footprint, deployment footprint, right? So that's a plus there. Performance with respect to like bundle size, it's like, obviously there's no problem there. You'll have a limited set of, you only have one trust domain, and you have sort of like a limited set of like downstream servers. So bundle size should be predictable and shouldn't be a problem. But I want to point out here that this is relative to our situation, because there are 2 possible designs from a SPIRE data store standpoint. You can have like vertical scaling of the database, where basically what this means in SPIRE is you have everything be one giant cluster using the same database, right? And that's not what we will do. And second is what we will do, which is like horizontal scaling the database. And the way you do this in SPIRE is by having like a nested deployment, where, as you know, like you sort of distribute the workloads, like entries and like management of like their identities to like many or n number of servers within a deployment, right? And each one of these servers would maintain those entries in a separate database, like would be a subset, be responsible for managing a subset of that the entries in that trust domain. So that is single trust domain. Next is maybe the other extreme, and this is a trust domain per cloud provider region. You might recall that I mentioned earlier that we are in 100 regions, and this is it's again like it's dynamic. We keep adding regions. We keep allowing our customers to provision workloads in different regions, new ones, right, and different cloud providers. So the diagram here shows 5. 5 shouldn't be a problem, obviously, but this is just to show the model. If we were to implement this, you'd see like more than 100 of these boxes instead of 5. So going through the 4 areas again, security, this is good because this is probably like the finest grain you can get. It's at least specific to our situation. So this is, and what this really means is that if you have a compromise in like one of these trust domains or one of these regions, you maybe break federation, you respond to that compromise, you restore trust and federation relationships after you respond to that compromise and everything is back to normal. Availability, from an availability perspective, then it's also like a similar story there, because if you lose one of these trust domains entirely, like it shouldn't have any effect on the rest of the SPIRE infrastructure. Operational overhead, it's not so great because this is, relatively speaking, for us, it's the biggest deployment footprint, and also like it's more and more federations or federation relationships to manage. Right, from a performance perspective, this is where we will definitely either now or potentially hit the bundle size issue. Right, and like I mentioned earlier, even if our current situation isn't a problem or works fine and doesn't hit like any problems with this limitation, in the future we might keep expanding, adding more regions, which means more trust domains, which means bigger overall trust bundle. So that is many trust domains. Now the third thing is maybe the sweet spot is the thing that we'll actually go with. And this is, if you take a look at the diagram on the left and right hand side and the bottom, like you have one trust domain per cloud provider. Doesn't have to be exactly one, but like the idea is to go by cloud provider and limit the number of trust domains we have in each, maybe just a few. So we'd have at most like total of 10 trust domains maybe. And then control plane, like a separate control plane trust domain that federates with all of these. Going through these 4 areas again, from a security perspective, it's not as fine-grained as like the previous one, but you still do have some level of security isolation. Everything's not just like just a single trust domain. From an availability perspective, again, relatively speaking, it's not like the previous one, but we do have some level of resiliency where if one of these trust domains go down, shouldn't have an effect on the rest of them. From an operational overhead, the footprint now is smaller compared to the previous model. And then it's, like I said, like won't be more than like maybe 10 at most trust domains. From a performance perspective, this is, the bundle size is now predictable because you have a limited number of trust domains. That shouldn't be a problem. And then within each trust domain, we're going nested. So the database shouldn't be a concern as well. Like the database being the bottleneck shouldn't be a concern. So that's that. Next, I want to talk about the problem that presents itself in this situation, right? Is managing registration. We're going to potentially have many SPIRE servers. And as you know, registrations are not just at the root level in a trust domain. You register things in a nested SPIRE deployment at like the downstream servers or cluster of servers themselves. And so the solution is a centralized registration service, where this may be a part of like your control plane if you have one, and it's basically responsible for making all the registration requests to like various SPIRE servers, and your workloads that are responsible for provisioning workloads, or your services that are responsible for provisioning workloads, then call it to make registration entries or requests as they provision workloads. Authentication, I mean, this isn't something we invented, but like you can have admin SPIFFE IDs known to all the servers as a part of their config. That SPIFFE ID is basically, represents the centralized registration service. So so then, that becomes just a part of the config. And even if the SPIFFE ID belongs to a different trust domain, these servers will accept that like a valid SBID with that SPIFFE ID if they are if their trust domain is federated with the SPIFFE ID that SBID is coming from. From an authorization perspective, only a known set of services or SPIFFE IDs are allowed to call that centralized registration service. And so you'd end up with something that look like this. This is like just a conceptual model. If you look at the left-hand side of this diagram, control plane trust domain has that huge triangle in the middle, which is the workload registration service that I spoke of. And then you have service A, service B, or maybe think of these as services that are responsible for workload placements. They already know or have the coordinates for a workload they're trying to provision. They then call a WRS or workload registration service to make registration request, and the registration service makes out the appropriate SPIRE server on that information passed from these services. The right-hand side of the diagram shows a subset of what the actual model would look like. The actual model would have like many clusters of these, and each one of them will point to a database, obviously, and that's per cloud provider. And then on the back to the left-hand side, the registration database you see at the bottom persists the intent of registrations. So you could replay the intent on failures and disasters and whatnot. Or if you want to rebuild your like one of these registration or one of these SPIRE servers as far as like registrations for any reason, right? And that's also how you get like eventual consistency. Maybe like we have a job that keeps running, that keeps syncing that data. That is all I had, but I also had, by the way, like a couple of slides to talk about an idea that we're actually using for measuring the SPIRE server CPU utilization and load testing in general. But I do want to take a break here and see if people have questions before maybe I move on to those slides if we have time.
I think there was a question around, is this workload registration service in-house solution?
Yes, it is. So SPIRE exposes an API for registrations. And all you need is like, basically you need to register an entry as an admin entry. And then like in one of the trust domains, right? And then use that SPIFFE ID as a part of, for that admin entry, use that SPIFFE ID as a part of like the config for all the SPIRE servers you intend to like, have them accept registration requests from that SPIFFE ID. And then use that or have your, your registration service be basically, the workload that's entitled to get that SPIFFE ID. And it simply just calls, uses the SDK that SPIRE already has to call the registration entry API.
I think Eli has his hand raised.
Yeah, thank you for the presentation. That's awesome to see things running at such scale and learning about the iterations on the architecture as well. I'm curious, like how long it took for you to develop that registration service?
So it's actually work in progress still. But it didn't. So yeah, I mean, relatively speaking, I don't think it took long. We have like our service foundation team is awesome. Like we have this framework to like sort of bootstrap new services quickly. And so, that's something we benefited from. Yeah.
So it's a part of you're basically integrating this workflow into your service that's existing inside the organization as well.
Correct. Yes.
Thank you. I think Roy has a question.
Roy.
Thanks a lot for this presentation. Really informative. The question that I have is, this is the model that you showed is for one application, or do you repeat the same model for like multiple applications? So let's say if you have 7,000 application and if you want to keep all of them separate, would you repeat this 7,000 times, or you will keep all the applications the same?
Yes, sorry. By applications here, you mean workloads, or what do you
Right,
mean
and
by application?
application would mean multiple workloads trying to work together to provide a solution or provide a.
Right. Yeah, so this model would be like one per environment. Sorry, let me see if I can quickly go to, yeah. So this, what you see here would be one per environment, right? And by environment here, I mean like the build stack and production. I'm not sure if this answers your question.
Yeah, no, I mean, yeah, I understand this. What I mean is, let's say you have one payment application, right, which is processing, which has a front end, back end, and multiple microservices. Would you deploy all of them together, and then this would form your trust domain? Or let's say there are multiple payment, one payment, two payment, three, you would create 3 trust domain for 3 payment application.
Yes. Okay. So I take it you're talking about workloads, right? And so like, let's say you have like this payment application, payment 1, payment 2, and like production, and they're supposed to be running in data plane, for instance, right? Or in some trust domain. They're either both in the same trust domain or they're in separate trust domains, but they're able to talk to each other because of, trust domain federation, for instance. So yeah, I mean, these are workloads you're talking about. There'll be this perspective that you see here, or this diagram. Let's assume like these 2 workloads are a part of maybe the control plane trust domain that you see up top. So there'll be like simply just workloads registered in that trust domain. And they should be able to talk to each other because they're a part of the same trust domain. Or if like one of them is registered or is a part of the top trust domain and the other one is like in any of these bottom ones, and these 2 trust domains are federated, they'll be able to talk to each other.
And if you want to keep them separate, as in 2 different applications, they don't really need to talk to each other. So would you create entire thing for
got
each?
it. Okay. If you're talking about the same environment, and if you have maybe a category of things like that, right? It's not just one service. You have maybe a bunch of services that need a certain level of security isolation. So then maybe you'd group them like that, and you'd say, okay, so this trust domain is separate, nothing is federated with it, or it's only one-way federated with something where identities issued from that one trust domain are accepted in other trust domains, but not vice versa. So that's how you would go about this generally, I think.
Okay. Thanks a lot.
No worries. Yeah, this question is like more general about SPIRE. So if any one of the maintainers has anything to add, feel free, please, to shed some light as well, or your perspective.
Cool. There is another question from Alex. Do you have service mesh Istio? And the number 2 question is, are you using SPIRE Kubernetes controller manager?
Very good questions. Yes, the answer to the first question is yes, we do. Not our whole, entire infrastructure has service mesh. Some parts of it do, and these parts will integrate with SPIFFE SPIRE. So, the source of these credentials that the service mesh uses or the certificates will be coming from SPIRE. So we do have that in some parts of our infrastructure. Then the second question is, do we use Kubernetes controller manager? Right? I'm assuming you're talking about the registrar here. to do like automatic workload registrations? So the answer is no, we're not, because number one, we're using cloud provider node at the station. And so the registrar doesn't work with the cloud provider node at the station. Number two is, if you remember, I spoke about like multi-tenant workloads and like potentially one pod having hundreds maybe of workloads. And so there is also like a limitation there where we can't use the Kubernetes manager controller. We need like a more, how do I say this, a more like a flexible way to register these workloads, right? Through like something more maybe powerful. Maybe powerful is not the right word, but maybe something more flexible and customizable, like a workload registration service.
Cool. Any other questions?
I see that Dave has his hand up.
Yep, Dave.
Yeah, hello guys. Yeah, thanks for a great presentation. This covers so much of just the fundamentals of designing a multi-cloud architecture here with Spire. In fact, I think it in a way, it made it sound so simple. It makes it really sound like it's like it's very simple. And there's still some complexities under the covers that I'm sure that you have to grapple with. What are you using to manage your federation relationships between disparate clouds, for example?
Yes, great question. So, so the first iteration of this is going to be all probably through infrastructure as code, right? And then, and I think the way I see this is like it will, you know, it will have some sort of evolution, like where maybe eventually we'll have some service that manages that. But also with federations, something that we are looking at that I think is a project that is in its early stages is Galadriel. I'm not sure if you've heard of it. If you haven't, that's something you know, you should take a look at. But we are looking at using Galadriel also in the future. But yes, to answer your question, currently it's all infrastructure as code. Eventually, it's going to be through like automated through some service. And the reason, yeah. So by the way, like it really depends on the situation, right? Like oftentimes, like you might find yourself not needing really a solution to manage federations because you have like a small set of trust domains, not a small, but I mean like a predicted static almost set of trust domains that you just need to bootstrap and provision once and call it a day, right? But what if you have like an infrastructure where like you're having to always like, you know, introduce new trust domains? I think that's when you want to think about like a service or like a way to automate like managing federations. Yep. So hopefully that's that answers your question.
Yes, but if I understand it correctly, it's the federation really is it's Spire server to Spire server, right? It's not as simple as doing federations between the root level servers. So you must have something in this infrastructure for as code. You must have specific sets of servers that are federated in the cases where it's required, or you tend to make the federation more general, even if there doesn't happen to be a workload under that Spire server that really is using it.
Oh, so federation, by the way, is at the trust domain level. Is that what you were saying? That it's that you think it's not on it's scoped to the servers, not the trust domains?
Yes, federating between the root level servers.
Yes. So federating, so you basically, yeah, you federate trust domains. It's at the trust domain level, right? But the config is at the root level of each of these trust domains. And so if you have, for instance, you know, infrastructure as code, Terraform or whatever, that provisions these trust domains, in theory, you can just like bring up these trust domains and like add the appropriate config to establish these federation relationships, right?
Okay, thanks. And that handles
Yes.
all the downstream servers then.
Yes, it does, exactly. It does handle all the downstream servers.
Okay, great, thanks.
No worries.
Right. Evan, you had your hand up too?
Yeah, I think I might have got a partial answer in that last one. I was curious about, so I heard, I heard you're using the cloud-based node attestation mechanisms, and then you have this registration service, which registration service must know something about the cloud topology in order to create the registrations against it, right? And so I'm curious, like, you have like in-house like provisioning flows that are turning this stuff on and then know about the infrastructure they turn on and then call your registration. So are you using like Pulumi or Terraform, this kind of like, can you talk a little bit about how all that works?
Yes, absolutely. I think if I'm understanding you correctly, you're asking about in here, like, are you talking about like, these the services that are responsible for scheduling workloads?
Exactly.
Yeah.
Service B here.
Yes, they already have like some knowledge of the workloads that they're provisioning in the cloud, right? Remember, this is our model, right? Like when a customer logs in to Confluent and in our UI or even through like API or CLI, we allow them to provision workloads in any cloud that we operate in, any cloud provider, it's AWS, GCP, or Azure, and also like a set of regions, right? And so if you think about that, like in our control plane, we do have like services that are responsible to do that kind of stuff, right? And so they already know coordinates of things. Like I'm supposed to provision this workload in this cloud provider and in this region based on the customer request, right? And so along with that, they have like other information about the coordinates about the workloads. Workload registration service then keeps like some sort of a mapping, right? Like it says, I know that the SPIRE server for AWS region XYZ is this. This is the host address for it, right? And so then it makes that resolution and then uses the workload API to get an SBIT for its own, right? And it's SBIT, like I said, it's an admin SBIT. Then uses the SDK to make the registration request.
Gotcha. Makes sense. Thank you.
No worries. By the way, this is another thing we've been thinking about is like, what if the SPIRE server, what if there is a SPIRE server plugin that consumes registration entries from like a cloud provider queue service, right? And I see you guys smiling here. Maybe this is something, I don't know if you've been thinking about that or not.
I'm smiling because everyone who's been dealing with Spire development adding another layer of plugins in there. I did it on my own as well at some point.
Yes, so this maybe would be, like the next iteration of like this whole concept of registrations for us, or an area we would look at. Just because it offloads some of the, I think some of the protection measures you have to put in place, right? Like in terms of like exposing this stuff over the internet, and what kind of protection am I adding at the network level? And then you have to worry about like something else being an admin in your system. What if that something else gets compromised? And what's that threat model look like, right? What if somebody's able to mint further admin SBITs? So things like that.
I know we have about 5 minutes left. Any questions for Omar or any of the other presenters too? Thank you for all the questions.
Thank you guys. Like I said, I have a few more slides, but we don't have time maybe. I think that, and also I think Evan wanted me to talk about like my contribution, but also there's no time. So maybe performance, like load testing, and like my contribution can be, something that I can share in like future instances of this meetup.
Yeah, absolutely.
Don't worry, this was even better than contribution experience. Maybe we can save the contribution experience talk for KubeCon.
Perfect.
Yeah, I
Thank
think
you.
performance is also interesting topic based on a bunch of questions people asking in the slide as well. So.
Yep, 100%.
Thank you.
Any final questions? I'll let you guys go. Thanks again, Omar, Evan, and Augustine for presenting today.